Good afternoon, everybody. Let's see if we can uh, do this quickly so I can um, have more short videos. And this time around is the turn for reduce with this extra parameter. Yesterday in the night, last night, we review reduce only within binary operator. Check the live session if you didn't see it. It is time for us to go with this version of reduce, and let's use uh, JShell. Look at this. Yesterday, wondering if we should import this in order to use it, but JShell has it loads some packages for you, so you can use IntStream. Let's go in. Look at this. It gives you some recommendations. Now we have a stream NS of numbers, and let's see what we can do. I'm going to use this to represent our stream. Remember, your stream is like a host instead of. Don't think as a list. This is only a representation. This is a number 4. It's not a 9, number 4. And this is what we have right now in JShell. And what can we do with this stream of ints? We can perform a reduce operation on them, and the reduce operation will give you an int. Yesterday it was an optional int, but this time around is int. Why? Because if the stream is empty, you will get your identity back right away without any further ado. Uh, okay, let's write this thing. Int, it's easy, it's an int. And in binary operator, we discussed this yesterday. In just in case you don't want to see the entire video, it's an specialization, condensed form of by function. Okay, because the three type parameters are ints, so you get this instead. And since it is a functional interface, it can be target of a lambda expression or a method reference as the API states. Um, I put an alarm so I keep myself on track. Okay, but it can be more faster, like and practicing guitar, because I don't want for you to be here like an entire hour for this topic. So let's do this reduce, and I will write 0. Okay, why? Because I'm going to perform the sum of the elements of this stream. X plus, where is my plus y? And the sum is 10 as you expect. 1 plus 2, 3 plus 3, 6 plus 4, 10. So why are you using this? Okay, let's create another stream and let's call it empty. Empty. Now let's see if we have some empty here, and we have empty with the parentheses added, which is great. And you have your empty. Now let's do the same operation, reduce, the same application, the same invocation of reduce, of the method reduce on the empty string, and you get 0. And you will ask yourself, why is 0? Well, it is here. Why did you say something like this? You will get that number. So think about this for a moment. If you give an empty string, you will get immediately the number that you are placing over here. And for the sum is 0. Look at this. Where is this thing? It is already processed. We wrote empty instead of ns. We can fix that very quickly. Look at this. 10. And someone will say now, I want to know what's all about. In minutes. Uh, okay. This is ns and empty. It says empty. Is this thing empty? So what's the sum of an empty string? What's the sum if there are no elements to perform a sum, a summation? If that's a word in English. You can think and say it's 0 because there are nothing to add. There is there is nothing in here, so the summation of this will be 0. But as you saw, you are free to put whatever you want in the reduce call with this number. If someone is asking why this number is from the Marvel universe, um, okay. So why I'm mentioning this? So be careful what you put in your identity. This is related to mathematics, and the identity element for the sum is accepted to be 0, and it makes sense. Okay, now let's see how it works for the non-empty uh, version. You have your identity. Let's change colors. This is your identity. And look at this. We have this lambda expression x, y, x plus y. But guess what? This identity will be used as the y at the beginning. So whatever you're placing here, and we can verify that. Look at this. Where is our code? Okay. Look at this. So this y at the beginning, it will take the value that is here. And you can call it accumulator. This uh, term comes from some books. Uh, and it says, okay, so x will be one every each one of these, but then y at the beginning it takes the value of your identity, and so you perform the sum. 1 plus 0, you're processing the stream is 1. Now your y would be 1. 1 plus 2, x is 2. Now this is equal to 3. Now your y will be 3. And you add the next x, which is 3. Now is 6. Y is 6. Plus the next x is 4. You get the final result of 10. I will try to make a visualization. This is for you to exercise your imagination, see something spinning around in here. Look at this, how beautiful. Look at this, and taking the place of the x, and the y transforming itself as any summation happens. But let's suppose I develop some time to come up with a Blender visualization of this. So for the time being, I hope this is clear. Now let's try with the product version because it is interesting. We will use the same stream. Okay. Here is our stream. Hopefully you are able to see it. Let me check. What's my face? 11 minutes, 12 minutes. I need probably. I don't want to be so fast that you can't understand anything. I don't want to be so slow so you can be, oh my God, this guy. I'm falling asleep. Uh, so we have our NS again with 1, 2, 3, 4. Well, now let's use, you might be tempted to say, now I want to multiply them. And you're using this symbol for multiplication, asterisk, and you get a 0. You say, why? Uh, well, from mathematics, since the y will be 0 at the beginning, 1 times 0 is 0, 2 times 0 is 0, until you get a 0 back. So you need to choose an identity that makes sense in the operation that you want to perform. In this case, multiplication. And again, from mathematics, and if you are saying at this point, no, I don't know from mathematics, because it happened to me in the past while reading some books. The books always says from your high school mathematics, and I was, oh my God, come on. So I at some point I review a little bit of mathematics. So if you don't know, there's nothing wrong with that. There is always time for you to review some elementary mathematics. Okay, uh, and we will choose 1. And now you get your multiplication because 1, the y at the beginning. Look at this. Then we have this. Now it's 1. 1 times 1 is 1. Now x goes like this. Y is 1. Okay, 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is, because x is now here, 6 times 4 is 24, which is here. 24. All right. Then we are back to the empty version. We're going to try this with the empty version. What is this thing? Where's the empty? Empty. Remember, we will use one, and you get one. And someone will say, that's because you're placing one here. What if you place 3,000 in here? You will get 3,000 in here. But if you want to be consistent, you will know from. And in here, I asked Google. I searched Google for this because I asked myself, there is no way. For the sum, it makes sense that zero is the identity of uh, the summation. If there are no elements, the sum is zero. But for multiplication, they say it's one. And you will say, well, it makes no sense because if there are no elements, why the product of no elements is one? That makes no sense to me. So I asked Google because it doesn't make any sense to have nothing and have one as a result, as a product of nothing. And it says that it's all about having consistency for mathematical properties, if that says something to you. So I interpret the phrase as we are saying that it is like this. We are saying it is like this. So the mathematics can work, and it works, and they are right in a sense because if you look at around, there are a lot of devices using mathematics based uh, on this kind of definitions. So this is by definition. You will say, okay, they're saying this, it works. So the world, digital world, well, not digital because we have analog devices based often on this. So it is just because it works, okay? But if you're trying to make sense out of this, you will say it, it is nonsense. But it is what it is. Now, if there are some mathematician watching this in the comments, he or she, and say, how do they say? Well, the phrase was, so we have consistency in the mathematical properties, and I interpreted that as that's the way the mathematics can work. Other than that, we won't have anything. Uh, but don't be tempted to trash talk mathematics for things like this. This is a beautiful subject. Back to programming, we have our version of empty, and we have our version with the elements. If you want to understand this thing, you will find yourself looking at another programming languages. Uh, JavaScript is one of those. And in JavaScript, look at this, we have reduced the same name as in Java world. And they use the word accumulator and they have an initial value. They are performing the summation of this. Zero is the initial value, and they have the accumulator. and they have the current value, and they're using accumulator plus current value. And you will say, you said that why it's the accumulator, and in here it seems like it's X. But it happens to be that we don't know how reduce is implemented in the, you know, how this thing is implemented underneath, under the hood. So perhaps they have this kind of switch because there are some variation of this reduce operation. Okay, besides, they have the initial value over here, which is in the place of the y. But still, it's kind of abstracted. Okay, so you went to another programming language called Haskell, and you'll find yourself taking a look at this function called fold, which is, according to the books and the literature, another name for reduce. Mm, They say these names appear in this fashion, but I don't think if those names are interchangeable, or if these things have a deep meaning than reduce. But in here you can see that hopefully we can convey this information. Df is the function, or the, in our case, the binary, the in binary operator. Then we have our identity. Look at this identity, and this is used to extract the elements from the list. The same as you go with a for each in Java. In Haskell, you say, I will process the X. Okay, we have an internet interruption. 22 minutes, too long. Um, Hopefully you enjoyed this. I have been watching videos 2 hours, 2 hours. And just to finish or up this time around, where is it? I got interrupted. Okay, so I wanted just to mention this. If it's clear here that if the stream is empty or the list is empty, you get your result, your identity immediately. Look at this. Okay, I'm going to finish the stream because this thing has started to uh, complain. The internet will cut, or like, I don't know. So the next episode, the last, probably two, one, I don't know. I wanted to do it in this one, but the internet has started again. Mischievous. uh, we will take a look at uh, to warm. We will be taking a look at this reduce, but in the stream, what is this, a class or an interface? Interface in the stream interface. Uh, okay, and then go with the crazy one in here and see what's going on in here. So thank you very much. I hope you like it. See you any other day. Bye. Have a good one. Happy weekend, by the way.